Alright, students. Continuing on. 5.4. Are we okay? Girls. Why not? People are allowed to move. I have not assigned seats. If you don't want people to move, I will assign seats. Do you want me to assign seats? Okay. If you don't want people to be able to move shares, that's okay. I can tell everybody where to sit. But I'm not going to tell one person they have to sit in one spot. Alright? If you want, I can assign people seats though.
So may I change that seat?
No.
Hey!
You
Not
are
fair,
you are corner team.
No.
Everybody else is allowed to choose their seats.
So next
All right.
week I can choose it. It's after 14 days.
Yeah, once it's been 14 days, you're welcome.
Yay!
You're free from my quarantine. Alright, so continuing on, where were we? Oh, I want
7B.
7B. Oh, I'm getting ahead of myself. 7B, 5.4 still. I want to get to. Alright, wait. Why does this look wrong? Oh, 6.4. Okay. Alright, there we go. 7B. F of x is ln of x. We take ln of x. What will we get after a vertical stretch by a factor of 3, followed by a translation 2 left and 1 up? Okay, so vertical stretch, b stretch by a factor of 3. Okay, our h of x is going to be what? Do you want me to keep calling you guys? That seems to work. What will I get? Oh, somebody really wanted to be chosen? Oh, Olivia keeps on volunteering. Wow. Olivia. Okay. Oh. Alex. What is it going to be after vertical stretch by factor 3? Ln of x. Vertical stretch by a factor of 3. Hannah, after we do our translation 4 units right and 2 units down, what do we get? Like this? Or outside? Keep your glasses on. Like this? Is she right?
Yes.
Yeah. No.
No.
Yeah.
Yes.
Yeah. No. Try again. Okay, Hannah. Put you back in the pile.
Why wrong?
Try somebody else. It's. Oh wait. 2 left and 1 up. Sorry. 2 left. I did the old. 2 left. One up.
7.
Hannah, do you want to change your answer? Hannah, do you want to change your answer? Plus 1. Very good. So we should get 3 ln of x plus 2 quantity plus 1. We all feel good with this? I kind of like the transformation.
I'm surprised that.
Students, you're just slowing yourselves down. And that means you're going to have to study more at home. It doesn't affect me. The quiz, the midterm's already made. I'm trying to help you guys.
Okay, okay.
Okay? So, I think if I were you, I'd be very happy with transformations right now. Because you guys worked really hard on them at the beginning of the year. And now that you understand them, it's like all these problems just free. You're like, oh, 6.4? I learned that at the beginning of the year. It's just the same thing, just a different function. Make sense?
Yes.
Okay. Angus,
Yes.
8.A. Can you tell me what the domain would be of that one? 8A. tell me the range.
Domain is
Range.
Let me see.
Jake, tell me the domain of 8B, and Ray, Serena, you're gonna tell me the range. Wait until I call you, ask you for your turn. So Angus, you first. Domain of 8A.
2 and infinity.
2 to infinity, including 2?
No.
No. Kyle?
Infinity.
Shh. I'm gonna tell people whether they're right or wrong in a second. Okay? Kyle?
8.
8A. Range. -1. To infinity. Alright. Jake?
R.
R for the domain.
Mm-hmm.
All real numbers. Serena?
Hey, wait.
To infinity. Are they right? Let's take a look.
3 to infinity.
So, the domain of A, which is -2 ln of x plus 3 minus 1. Do you want to change your answer?
Yes.
Yes to what?
3 to infinity.
Ah, much better. 3 to infinity. Alright? The domain is really sensitive to left-right translations, right? This is translated to the left 3. So it's actually going to be -3 to infinity. Angus, do you see how your answer is still wrong?
What?
It's -3 to infinity.
I said -3, but.
Oh, I heard 3.
No.
Think. Physics. Remember. It's the same question. What can I take the natural log of? Now, if you're like, oh, Mr. Mega, I don't remember, I don't know what I can and cannot take the natural log of. There's one graph you need to know. ln of x. Y equals ln of x. You should know what this graph looks like. It is a reflection of e to the x, right? So, just like e to the x will never be, e to the x will never be 0, ln of x, you cannot put 0 in for x. You won't get an answer. Because e to any power will never equal 0. Right? So, that's why this cannot be 0. If this is not 0, it can't be -3. That's the smallest, and it can go as big as you want. Is Kyle right?
No.
If I take my original parent function here, right, and I do all these transformations, I move it left 3, I move it down 1, and then I flip it over the y, over the x, and do a vertical stretch by a factor of 2. Not in that order, I do the stretches before I move it. What do I get? Still all real numbers. R.
Yeah.
Still gonna be okay. Alright? Are they right?
Yes.
Was Jake right? Is the domain all real numbers?
Yes.
Jake, would you like to change your answer?
No.
No, Jake's wrong.
Why?
Oh wait, no, it's not. It's all sorry. This is an exponential function. Sorry, different function, not the same function. Gosh. E to the negative x plus 2 minus 3. Is he right? Yes, he is. Very good. The domain's still right. Is Serena right? Yeah, my bad. Sorry, you're right. Is Serena right?
I think yes.
Yeah, we brought it down.
Yes.
Yay. What did we notice about 8A and B?
Inverse.
They are opposite.
They're not actually perfect inverses of each other. I wish that would be kind of
So
fun.
make up.
But their domain and range are actually opposite. Yes.
So the number A is B domain is mean all real number.
Yeah. Yeah. This and this are the same. Okay. I'm just teaching a new form. Yes.
What is ln?
ln natural log, log base e.
Log base.
Yeah. So ln is the same as log base 2.718. Right? Which is e. So instead of writing log base e of x, we write ln. That's because e is called the natural number. So this is the natural log. if you would like to hear more about E, there are many great videos online about E, or come talk to me outside of class, and we will just nerd out learning all the fun things that make E the natural number. Why we call it the natural constant. Question?
No question.
Alright, students, A, 9, A, B, C, and D. Quickly, I'm going to do this rapid fire.
Okay.
Ready? Angus. Oh, you already did this. I'm not going to choose you again. Hannah, oh, you got yours wrong. Hannah does A. Ricky does B. Ryan does C. And Tom does D. Okay? A, B, C, and D. Tell me, is it always, sometimes, or never true? Everybody, other students, you're going to have to grade them. Always, sometimes, or never. Tom, you got to figure it out. You got a 1 in 3 chance. Okay, so A vertical translation of the graph of f of x equals log of x changes the equation of the asymptote. A vertical translation changes the asymptote. Is that true? Always? Sometimes? Never?
No.
Never. Okay? Never. How about B? A vertical translation of the graph f of x equals e to the x changes the equation of the asymptote. Always, sometimes, or never, Ricky? A vertical translation of the graph of f of x equals e to the x changes the equation of the asymptote. Always? C. A horizontal shrink of the graph f of x equals log of x does not change the domain. Is that always, sometimes, or never true, Ryan?
Always.
Always.
I think.
Are you having a problem?
Mr. Mika.
I will correct them. D. The graph of g of x equals ab to x minus h plus k does not intersect the x-axis. Always, sometimes, or never, Tom.
Sometimes.
Are they all correct?
No.
Who's wrong?
We don't know.
A, B, or C, or D?
B.
Is A correct?
Yeah.
A is correct. That will never change it, going up or down. B,
Why?
I have this graph. Moving it up or down is not going to change the asymptote. The asymptote is x equals 0.
We don't know. Oh wow.
B, I have e to the x. Moving it up will change the asymptote. Always. True. C, a horizontal shrink of the graph, log of x, does not change the domain. So if I horizontally shrink this, so I make it a little taller. Okay, actually.
You know, A does.
Okay, a little more angular.
Taller.
Does that change the domain? No. That's correct. That's correct. And last one. Does it not intersect the x-axis?
I say it's always there.
It is sometimes.
When
Wow.
K is.
What we know for is
Correct.
I always.
Mr. Mika.
Yes. If k is negative, it will not. It will intersect.
But K is positive.
I didn't say that. Yes.
How do we know why sometimes? I don't know why sometimes.
So sometimes means not always.
I don't
Sometimes
know.
yes, sometimes no.
I don't. But I will know why sometimes, not always, not.
So I have a graph of a, b, to the x minus h plus k.
Oh, okay.
This graph, its parent function, looks like this. We're saying this will never cross the x-axis,
Yeah.
but if k is negative, it's going to be down here. So if k is negative, then it will cross. But if k is positive, it will not cross. So sometimes, depending on k.
Really hard.
Yeah. Oh, actually, also, another way for that to happen is if k is positive, but a is negative. Right? Because then it flips the whole thing. A reflection in the students, I am going to skip 10.
Okay.
Sad. But we can come back. What you're going to be doing is just making a rough sketch of the graph, describing the domain of the range, plugging in 12,000, describing the transformation. I think you can do it. Alright, so 5. The last section we are covering. Good. Fine. So we finished this section here and we're done. Okay, Jerry? We're almost there. Power through with me. We can do it. We can do it. Add that oil. Add that oil. Okay. So, properties of logarithms. And again, 6.5. Do we know our properties of exponents? Yeah, right? We do. So we basically know our properties of logarithms because they're very similar. So, just like 6.4, 6.5 is basically a free section for you if you remember your properties of exponents because they're very similar. So, the logarithmic function with base b is the inverse of the exponential function with base b. Therefore, logarithmic functions have properties similar to properties of exponents. Let b, m, and n be positive real numbers, with b not being 1. Let the product property, which says the log base b of mn is equal to, can anybody guess?
And
M plus N.
Log base b of m plus log base b of n.
oh, I know.
Just like we do with exponents.
Oh, hey.
How about the quotient property? Log base b of m over n equals
Log B.
Of M minus log base.
makes sense, right? We've done this with exponents. We can do this with logs. And the power property, and this is the last one, honestly, is the one I use the most. Often, this last one, to me, is the most common.
N times log.
Very good. N times log base b of m. These three properties are very important to solving log problems. Alright? And it's what a second ago I wanted to kind of start using, but then I held back because I wanted you guys to I wanted to teach it to you before I used it. Alright? So, now we can solve lots of problems using these properties. And this makes it so we can solve anything, a lot of things we couldn't solve otherwise. There's still a lot of these that we want to use our calculator for, but it's not bad. Alright, so 2. Use the fact that log base 2 of 3 is about 1.585. And log of 2 of 7, log base 2 of 7 is about 2.807. To evaluate log. We want to do log base 2 of 3/7. That's going to be what?
When you use 1.1585.
Yeah, this is going to be log base 2 of 3 minus log base 2 of 7. So that is going to be 3, I was told, is 1.585 minus 2.807. Doing that math, negative 1.222. B. Does that make sense, what I'm doing there?
No.
I don't need to use my calculator even. I could give you a test without calculators on this. Right? Because division property here, quotient property, I apologize. Quotient property says that I can split this and then subtract. And I'm told what these values are in the description. Good? Cool. Okay? B. How about the log base 2 of 21?
It's log 3 times 7.
Very good. Log base 2 of 3 times the log base, plus log base 2 of 7. Did you say times?
No.
Okay, good. Plus. Okay, now plus
2.807.
And now add those together, you get 4.392.
39.
Four point.
Make sense?
So what's the answer?
4.392. Okay. So next one, C.
Why C?
Log base 2 of 49. That is? How do I break this one?
7, 7.
7 to 7.
2 times log base 2 of 7.
Yes.
Or log base 7 plus log base 7.
7.
Log base 2 of 7 plus log base 2 of 7.
Yeah.
Times 2 7. And so that is 5.614. Done. We can do all those, A, B, and C. Sorry, being out of order. Good?
Okay.
What's your
Questions? Sherry? Questions? Alright, now, Sherry, help me on 3A. What do you get? We have ln, the natural log. This is a really more useful version of this question. 5 to the 7x over y. How can I expand this? I want to split this into lots of little logs instead of one log. First step, any guess? Use one of the rules we had. Use a quotient rule.
5x. The thing.
ln of the 7. ln of y. Very good. Well, we can keep on splitting it a little bit more. Okay. Kyle Wong. How can I split it again?
Over. 5x and 7.
5. ln of 5 plus
Plus ln
ln
x is 7.
x to the 7. Angus is ahead of you. Minus the ln of 1. That one's kind of stuck still. But the x to the 7th can be used to the product of the exponent rule. So this breaks into ln of 5 plus 7 ln of x minus ln of y. And this is fully expanded.
Why 7 ln?
Remember rule number 3, power problem. This is x to the 7. I can bring the 7 out. Right?
I didn't copy.
Oh! And yes! The last one, okay, it is log of base b of m. This is important to copy these things down when I write these. Right? Then, same thing but minus. And the last one, and I even told you specifically, the last one's the most important one. And Angus is just like, oh, I don't need to copy this down. Come on. Come on, Angus. I told you.
Okay.
All right. It's important. When I say it's important, it is important. Trust me. I make the test. Okay. So, B. Do you guys think you can do it?
I know.
Yes.
Log base 6 of 3 to the x plus to the 4. So, sorry. Log base 6 of 3x to the 4 equals, oh, we got 3 people left. Leo,
Okay, I know.
what do you think?
Log 6 and 3.
Well,
Log.
let's see if we can do it all in one.
Log 6 as 4.
Log of what?
6. Log 6 as 4.
Log
6.
6 to the of x to the 4.
Yeah.
We can go one step farther. Josh, what's the last thing we can do? 4 times the log base 6 of x. Make sense? There we go. And we fully expanded b. Notice everybody, I can change if I change this problem just to this, e to the 3x plus to the 4th, right, like this, we can do the exact same thing, right? E to the 3 plus e to the x to the 4th, right? But we can't really do the multiply out thing, right? No, can we? Yeah, we can. E to the 2 to the 4, no. E to the x to the 4th, is that same times 4 times e to the x? Well, that's e to the x times e to the x times e to the x. Is it? No. No. This is not right. Sorry. We can do the exact same thing if we had it backwards. If we had e to the 3 plus 4x, if we had this, it backwards, then we could write it as 3 e to the 3 times e to the 4x, right? Which is e to the 3 times 4 e to the 4th to the x. We could do it backwards, kind of like that. Anyway, it's not worth going over. Right, and Jerry, help me on the last one. Last one's tricky. Log of 3x squared over the cubic root of y plus 1. What's our first step? Jerry, first step. Log of three. Just 3 or 3x? Both are fine right now.
3x.
3?
It's okay. It's okay. It's okay.
Jerry, just guess. It's okay if it's wrong.
Just feel alright.
Okay? It's not. We're not done. It helps when you're awake during my class, right? It really helps when you're paying attention. Believe it or not, I'm not just doing nothing up here. So Jerry, come sit in the front. I will make sure you can hear me better. I must be too far. So, fully expanding log base 3 plus 2 log of x. Let me actually fully write this out. It's going to take a space. Log base 3 minus 2 log of x. No, plus 2 log x minus the log of the cubic root of y plus 1.
I know. 1 over 3.
Oh, Angus is so smart! Look at that! Angus noticed that this is the same as y plus 1 to the 1/3, right?
Wow.
So this is the log of 3 plus 2 log of x minus 1/3 log of y plus 1. Can we go any farther? No. The y, what?
Like y plus 3 to the power of what? It's a y3. 1 over 3.
Why is
1
three?
over
3.
1 over 3.
Why I see.
1 over 3. Alright? So, there we go. Notice that roots are just exponents in disguise. Right? They're just tricky exponents. We can write them as exponents and use these same rules. So the power rule applies to radicals. Good? Questions? Comments? Concerns? Alright. Now 4. Let's condense them. Alright. I'm going to do the same thing. 3 people. I'm going to choose you. Do A, B, and C. We'll tell you whether you got it right. Alice, you're A. Tom, you're B. Josh, you're 3. You're C.
Call me John.
Just do YC.
Alright.
Over.
A, B, and C. Alice, Tom, Josh.
What is content?
Condense means to undo what we did. Expand, make big. Condense, make small.
And then go on. Do we have to write it on the board?
Sure.
Either way.
I like that. Come on,
Over.
Measure the pig.
No, do not move backwards.
Josh. Huh?
Stay forward. I don't want you to affect Serena. Serena's healthy right now. We're going to keep her that way. Alright, while they're working, students, let's look at number 5. The change of base formula. Logarithms with any base other than e and 10 can be written in terms of common or natural logarithms using the change of base formula. If a, b, and c are positive real numbers with b not equaling 1 and c not equaling 1, then log base c of a is, Kyle, you're the only one who might know this. That works. If you want to turn it into base L. So that'd be, again, let me write that out. ln A over ln C. What if I want to make it log? Or if I wanted to make it log base 10, it would be log of A over log of C. This is how we can change the base. We do the log of the number that we want over the log of the base. In general, is log base b of A log base b of C. Okay? So the base can be whatever you want. Does that make sense? Write that in. Log base b of A divided by log base b of C. If your base is e, then you would do ln of A divided by ln of C. Alright, are we done? Okay, give them another second. Prove the change of base formula. Woo! We. Oh wow, the formula is written by hand. So you're tricky. Well, what we would do here is raise both sides, use our product of properties here, and then raise both sides equal. We'll do that in a second. Actually, I might not have time to do that.
Yes, that's so.
Yeah, I might just skip on. Alright, we're done. I didn't want just the I don't want massive level done here. Alright, ready? Let me correct them. Boys, find a seat. Alice, she came up with log of 24. Your answer is log of 24. Let's see. Log of 9 plus 3 times log of 2 minus log of 3. That is the same as log of 9 times log of 2 times 2 to the third. Very good. Divided by 3. So 9 times 8 divided by 3 is the same as 3 times 8, which is 24. Good job, Alice. That's correct. B. Now I gotta do this in a different color because you used red. Okay. B. We have ln of 3 plus ln of x minus 9. So that's the ln of 3 times x divided by 9. Very good. All right. Now what did he do?
Oh my God, that's wrong.
Then you tried to. Then you started trying to expand it. Oh, then he reduced the fraction.
Oh.
Oh.
Wow.
Wow.
Oh.
But x need to be 1 over 3 now, because both numbers need to divide.
I am.
How about, should the minus 3 go at the end?
I don't know la Serena.
Go.
But I'm just deciding whether this is. No, that's fine. Okay, so yes. Is this a 2?
It's the L. Oh.
This is what's this thing?
It's equal.
Oh, equals. Okay. All right, that's equals ln of x, and then what are you doing down here?
It's half.
That's Japanese. That's Japanese.
Get in your chair. Get in your chair. Okay, I don't know what he's doing down here, but this part does need to be done. But yes, the answer, ln of x over 3, is good.
Yes.
Alright? Now, let's look at this big answer.
Yes.
Alright, biggest answer today.
Let me like.
Log 1/2 log base 2 of x plus 1 plus log 3 times log base 2 of y minus 1/3 log base 2 of z. Woo-wee! So he did each piece. Log base 2 of the square root, very good. Log base 2 of 3, very good. Log base 2 of the cubic root of z. Good. Then he multiplied them all together. So 1/3 y to the third divided by another weird equal to thing, the cubic root of z. Assuming this is an equal sign.
Log of 2.
Oh, log base 2, you're right. Gosh, no.
Josh. Oh.
Log base 2 of this whole thing is correct.
So negative 1 over 3 times cube is nothing.
Negative 1 over 3 cubed. This would be negative 1 over 27.
But where is the negative?
It became the cubic root of the. You're the one who taught us that. Right? Didn't you say that? Yeah, you knew that. Alright. There we go. Boom. Please write in their answers. All 3 of them got it. Isn't it an easy section? I'm happy. I didn't even have to teach you that. You guys are just like, oh, Mr. Mega, we got this. We know this, no problem. So sadly, I'm running low on time, so I'm going to go ahead and just briefly look at the next page. Alright, so now, students who were gone, who were up here on the board, please on number 5, fill in the blank. The blank is log base b of a over log base b of c. Okay? Sadly, I don't think I have time to do the full proof. But basically, what we're going to use is the quotient property, and then we're going to raise both sides. Make sense? Okay, so there's actually 2 different powers. Alright, so let's go on to 7. 7. Evaluate the expression using a common logarithm. So this is what actually I used to have to do because my calculator wasn't as nice as yours, and mine didn't have bases going up. And oftentimes, lots of smaller calculators won't have this. Your nice graphic calculator is nice to you. So how can I write the log base 3 of 8 using log base 10? It's the log of what divided by the log of what?
Huh?
Log base 3 of 8 is the same as log base
10 minus 7. No?
of A, remember here, log base C of A, right?
It's ln.
What?
It's ln.
Both are okay. If you prefer to use ln, you can. It says using a common logarithm. There are two common logarithms, log and ln. Okay, log of 8 over 3, which is the same thing as ln of 8 over ln of 3. Both of them. When we get that, we type that into our calculator, we get 1.893. We all do that. You're not just watching me and going, oh, Mr. Mega, I think I can do that.